Uh, a bit about me, I'm a long-time Apache Software Foundation member. I'm a member of Apache Lucene, Solar Notch, and Mahout, some of the tools that I saw some of the presenters use here. I'm a co-author of a couple of books, the technical one being the Lucene in Action. I've started several companies, some sold, some transformed into bigger entities. In 2007, I started Sematex International, which I'll describe in a bit. And here in New York, I organized the New York Search and Discovery Meetup, which has about 300 members now. This is the company I founded in 2007. We're headquartered in Brooklyn, and we offer services and products around search, big data, data analytics, web crawling, and machine learning. This is the basic search experience that we're all familiar with. Summaries, keywords in context, blue links. This is a fairly specific query here I used. It has 3 words more, that's probably double than the average query length. So the search results are pretty good, plus Google has a nice big corpus that can really find what I'm looking for. But had I used something less specific, I would have gotten millions of hits. And the question is now how can we improve the search experience for the person? So there are several ways of doing this. We could offer users related searches as a mechanism to explore the search results in a different dimension. The key piece there is that you need to have really large query volume like Google has to be able to offer really good related searches. If you have search in an enterprise with a relatively small query volume, the chances are you're not going to have not going to be able to derive very good suggestions from the query logs. You could cluster the search results using bucketing documents in result set in groups. The problem with that is that it's kind of fuzzy, and personally I find that people don't like that. Named entities, I'm not going to mention them a lot because they're mentioned a million times already, but obviously you can extract entities from matching documents and offer them as additional criteria to drill into the search results as facets. And there's faceted search, obviously, which is built around structured data that's present around unstructured documents. You could call it metadata, which is great. It works well if you have such structured data. So here are examples of things I mentioned. The first example is the related search widget, which Google has turned off by default, but you can, from the left side here, you can, down here I think it is, you can enable it and get some pretty good related searches as suggestions. The next example is the clustering that I mentioned. I went to clusty.com. I guess maybe some other company bought that now. But on the left side you see the documents in the results set clustered dynamically based on their similarity, along with the counts of documents in each bucket, in each cluster. The problem with this that I find is that this is a little bit too fuzzy. Even though there are counts there, first of all, you don't know what exactly is in those clusters. Even though there are counts, typically these clustering engines take the top n hits and create the clusters based on that. They don't take the whole result set that may have thousands of matches for performance reasons, because clustering has to be done on the fly. And interestingly, when I reloaded this page, I got similar clusters but different ones. So I feel that that's kind of too fuzzy for a user, not being certain what they're going to get when they drill in. And in this case, the clusters were only 2 levels deep. Sorry, I tried looking for a service that offers named entities as a way of drilling into the results, and I couldn't find one. And there were guys from OpenText here. I was actually looking for their service, which they recently announced, where they do named entity extraction and offer named entities as a way to refine search results. But there's so many examples here of this stuff that I think no explanation is necessary. This is the traditional faceted search on the left from Amazon.com. This I find people find more useful because it's based on some very structured data. There is no mistake. You know exactly what you're getting when you go into a toys and games category in this case. You know exactly how many hits you're going to get. And this faceting can be, you know, n levels deep. Another way of letting users refine search results is using key phrases, which were mentioned here. There's a mention of topics, of concepts. I'm using the term key phrases. I think it's all more or less the same thing, similar thing. There are different types of phrases that you could extract. Here are 2 collocations and SIPs, statistically improbable phrases. And here's an example of one search service that uses this. There are not that many services that I know of that use this, but here's one, Cirrus, that shows both the facets up here and the key phrases at the bottom that you can click on and refine your search results. This is something that from 2 sites that we run, this Search Lucene and Search Hadoop. The reason I gave another example here is because it shows these are pretty bad phrases actually, and the reason for that is the quality of the input. In this case, in case of these 2 sites, we index a lot of mailing list messages, wiki pages for this Lucene and Hadoop open source projects, which means there is a lot of noise, people making typos, there are multiple authors, they use different writing styles and so on. As a consequence, you get all this, you know, not terribly useful phrases. You'll have to trust me that they're not useful if you're not familiar with what you could be getting. The nice thing here is though that the phrases have this little minus and plus which allow you to exclude or prohibit phrases from the results. Here's just a brief definition of these collocations that I mentioned. These are phrases whose words are seen together more often than you would expect given their individual words frequency. Statistically improbable phrases are phrases that appear more often in one corpus, in one set of documents than in another set of documents, typically called foreground and background models. We have these definitions here, and both collocations and SIPs are defined. They have pages on Wikipedia, which are useful. We can skip that. And this. This is a little the diagram that shows that you can combine collocations and SIPs to come up with sort of hybrid phrases that you can tune to be either more collocations-like or more SIPs-like. Beyond search, I feel like I'm repeating a bunch of stuff, but this is these phrases can be used to enrich content, to tag content, to provide sort of abstracts or aboutness of a document on the fly. You can use the phrases to link content assets, to provide navigation in a news system, to spot trends in social media, for instance, to monitor what customers are saying about the corporation, about the brand. All of these things have been mentioned throughout the day. Here's an example of phrases being used in context other than search. This is probably the most, in my mind, the most popular example of SIPs being used. They're used on Amazon.com, where Amazon compares the content of a book with other, I believe, with other books in its category, thereby extracting phrases that make this book different. They also have something called caps, which I believe are just phrases that are capitalized. This way they get rid of a bunch of potential sort of junky phrases. This is just a definition that you can see if you go if you go here and here, you'll see how they define SIPs. This is this is a demo of our key phrase extractor tool that in this demo simply pulls the feeds from Reuters, feed for technology and feed for entertainment. This is only for technology, and extracts various terms and phrases from the content. You can see that collocations and SIPs are are similar, but they do differ, and the key phrases is the hybrid combination of the two. I can skip that. This is an example of one of our customers where they described how they use key phrase extractor, and they use it to identify common problems that the customers are talking about in social media, and to detect topics that are starting to become popular. Here are some of the lessons we've learned through use of a tool like this. Garbage in, garbage out. I showed two examples of Amazon having really nice content, single author who uses the same writing style throughout the book, compared to the case where key phrases are extracted from open source project mailing list. We've discovered that while the phrases are nice, to really make them based purely on statistics, the language awareness, meaning part of speech, would really improve the phrases for some of our customers. Then filtering, I find, is needed in pretty much all cases, and the example here, England V, is something that I saw in open text demo of their semantic navigator product 2 weeks ago at a conference in Boston, Lucene conference in Boston. I saw this phrase, England V, and I was wondering what that was. And I clicked through it, and it turns out that this phrase was simply part of England versus another country's soccer team. So this obviously needs to be filtered out, but if it's based purely on statistics, this is going to look like a important phrase, which it's not. And that's it. Thank you.